Hey, for the binomial theorem. What? Binomial theorem. Binomial theorem. Binomial theorem. Well, I don't know if there could be a better intro to this lesson or not, but that was pretty spectacular if I do say so myself. Here today, we're going to do something we like to call the binomial theorem. Binomials, you may recall, are two terms. And what we're going to do is we're going to be expanding binomials to whenever they are to a power that is larger than 2. You already learned a shortcut way back in Algebra 1 if you have a binomial that has a degree of 2. But now we're going to start expanding things when they have degrees of like an exponent of like 3, 4, 5, 6. Oh heck, we'll just go as high as we want to go. So when you have your two terms, something you're going to have to think about is you have coefficients of your binomial expansion. These are called your binomial coefficients. In order to find them, you do what we call the binomial theorem. And so you can kind of read through this little box down below. And if you have x plus y to the power of n, your first term, you just take this to the nth power. Your next term, well, you're going to have whatever your coefficient is, blah, 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 all this fun stuff. It'll make a lot more sense here in a little bit. And here's how you find your coefficient, though. Okay, in order to find your binomial coefficient, you have to use this formula. And notice we're going to be using some factorials. Lovely, lovely. Another way you can, or notice that your whatever number is in front here, your subscript in front of your C, is going to go on top. Then you're going to take your n minus r to the factorial times your r factorial. Another way you can symbolize this is just saying n over r. So we can, let's go ahead and simplify some of these then. So if you have a 9c2, is what we'll call it. Well, what that means really is you're going to have a 9 factorial on top because this is your n, this is your r, and then on the bottom you're going to end up with a 9 minus 2 factorial times your r factorial. Bam. So let's clean this up a little bit. If you have a 9 factorial over 7 factorial times a 2 factorial. So yeah, you could type that into your calculator. That'd be real nice and boring. Or you could just say 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. Oh my gosh, that's so much more enjoyable. And just type it into your calculator, and then you have a 1 times 2 times 3 times 4 times 5 times 6 times 7 times 1 times 2. So if you remember last time we learned about canceling terms out on top and bottom, we have this 1 through 7 that can cancel, 1 through 7 here. And on top you could really cancel your, and this 1 doesn't even matter, this 8 and this 2 could be a 4 and a 1. So really you end up getting the answer of 36. Well, that's not too bad. I think I can probably do a couple of those. In fact, let's just go ahead and do that. So for B, you're going to do the same thing on B, except this is an 8c sub 0. So that's going to be an 8 factorial divided by your 8 minus 0 factorial times 0 factorial. Anybody remember what 0 factorial means? Yeah, you. Yeah, you there in the back. It means 1. That's right, Sam. Good job. So we're going to take an 8 factorial on top, which is just 8 times 2, 3, 4, 5, 6, 7, 8. And on the bottom, well, 8 minus 0 factorial is just, well, it's just a 8. So you have to multiply all those. And then if we have a 0 factorial, remember that is just a 1. So what happens is everything cancels out, top and bottom. So if everything cancels out, it doesn't mean you get a 0. That means really what you have left is just a 1. You have a 1 over 1, which is 1. So pay special attention that whenever you have a 0, back here at the back or at the front, doesn't matter, then that's going to end up being just a 1. You're going to get a coefficient of 1. So let's do C. Well, what this really means here with C is that really means you have an 11 C sub 4. So if you do up through 11 and then you do up through 4, we can do that if we want. Write them all out. Sure. Why not? This is a great time. You may have noticed a pattern by now, because if you have a 4 on the bottom and a 7, you're going to be able to simplify this a little bit. Actually, I guess I skipped a step, didn't I? So this would be an 11 factorial on top over 7 factorial, 4 factorial. Well, how to get the 7? Well, how to get this 7 right here? I took the n minus the r. So then this is going to be all over 7 factorial. So you write all these out. Oh my gosh, I'm getting writer's cramp. And then you have a 4. So let's cancel 1 through 7. Those are gone. 1 through 7. Those are gone. Well, 2 times 4, doesn't that cancel out with your 8? Sure, that's a good way of thinking. This 3 will cancel with your 9, make that a 3. So what you have on top is a 3 times 11 times 10, which is just 330. I love canceling. I love fractions. This is a great time. I love it. Let's go ahead and put our box around here. And if you notice for D, when you do letter D, this is going to end up being a 5C sub 5, which is just a 5 factorial over 0 factorial times a 5 factorial. Well, notice a 0 factorial is just a 1. If we take a 5 factorial divided by 5 factorial, you just shorthand this and say, well, that means this is just going to be a 1. And that is how you can use your lovely factorials